6.5a, multiplication and division of radical expressions. Let's just get started here, skip the bumblebee part, and jump right into example 1. So multiplication, and I had mentioned this in an earlier section, that if you treat the radicals as if they were variables, that helps you to be able to follow the correct rules. So for example, if this were 3x times 2x, we'd multiply the 3 times 2, and then we'd multiply the variables. We're going to do the same thing over here. We're going to multiply the 3 times 2, and we're going to multiply the radicals. Easy peasy, we're all done. Okay. The only other thing that you want to look at as you're doing this is the square root of whatever number is under here to see if it can be reduced. Now, obviously, the square root of 35, there are not two numbers you can multiply by to get 35 that you could take the square root or reduce, because we get prime numbers for both of them. So the 6 square root of 35 is as much as we can do. All right, bringing us to example 2, where we have the square root of 3 times 2 square root of 6 minus 5 square root of 12. Now there's a couple ways to do this. The first way is normally just to multiply using distributive, and we get 2 square root of 18 because we multiplied this times this, and then we multiply 3 times, or the square root of 3 times the square root of 12. Okay? And then we reduce from there. But before I reduce this one, let me show you another option. When you get numbers under the radical sign, if they can be reduced first, it's usually a good idea to do that, because sometimes this number under the radical sign can be in the hundreds. So if you can reduce this first to 2 square root of 3, so instead of 5 square root of 12, we do 2 square root of 3. And you can tell real quick if this is actually the reduced version of this by squaring this and multiplying by this. Do I get my 12 back? Yes, so I know this is correct. So I get minus 10 square root of 3. So now when I distribute this 3, I'm multiplying this times this, because this is the reduced version of this. So the 3 times 3 is easier to multiply than 3 times 12, or if this were 15 times 16, it's just easier to reduce it first. But since the book doesn't do it that way, well, yeah, when do I ever do it the way the book does? We'll just do it the way they did it there, because this one's a fairly simple one. So we take the square root of 18, which if you write this as two numbers multiplied together, they give you 18, and you can take the square root of 1, okay, minus 5. Square root of 36 is just 6. 6 times 6 is 36. So we can take the square root of 9 and get 3. Okay, so then we have 6 square root of 2 minus 30 as our final answer there. So these aren't too terribly bad because they're multiplication. Multiplication is always so much more fun. All right, so let's jump to example 3, square root of 3 plus square root of 5. And we're going to multiply that by 4, the square root of 3 minus the square root of 5. And we're going to use the FOIL method. So remember, FOIL is first. So when I multiply first, I get 4 square root of 9. Then I have my outside, let's do that in blue, minus square root of 15. Okay. Then I do inside, and I have plus 4 square root of 15. And then I have last, this times this, minus square root of 25. Okay, so remember, I can multiply anything. So 3 times 3, the square root of 5 times the square root of 3 gave me the square root of 15. Okay, so now I'm going to combine like terms here and do some simplifying. Square root of 9 is 3, so 4 times 3. Minus the square root of 15, can't do anything with that. Well, in fact, what I'm going to do is I'm going to look at square root of 15, 4 square root of 15. So this is negative 1 square root of 15 plus 4. That's plus 3 square root of 15. Negative 1 plus 4. Minus square root of 25, which is 5. So I have 12 plus 3 square root of 15 minus 5. I combine these two, and I get 7 plus 3 square root of 15. The square root of 15 cannot be reduced, and therefore I am done and ready for example 4. All right, so example 4 is square root of x plus 3, and we're going to square that. We're going to use the FOIL method, so what I'm going to do is I'm going to write it twice. Makes it a lot easier. So first, square root of x squared, and outside, inside, and 9. Okay, remember whenever this number and the index are the same, we can get rid of everything and we just have the x or the number or whatever's in there. I can add those. Remember, I'm adding them, so I'm just adding this and tagging on the square root of x, and then I'm going to have a 9 there. Okay, so at this point, we are done. I can't reduce this any more than what it is. Okay, bringing me to example 5, 3 square root of x minus 2 square root of y, and we're squaring it. So let's do, So for this one, we can use the FOIL method. We just write this out twice and do the FOIL. Or we can remember the formula, which we don't remember this very often. So usually what is suggested is go ahead and use the FOIL method because most of us remember that rather than trying to remember this formula. But let's use this formula just as practice because it's got a number minus a number and the whole thing is squared like that. So I'm going to take my first term, square it like I did here, minus 2 times my first term times my second term, and then I'm going to square my second term. Okay, so once I have that, now I can start simplifying here. So 3 squared is 9, square root of x squared. Remember again, this number and this number are the same. We can just write it as x minus, okay, let's combine all of this. 2 times 3 times 2 is 12. Square root of xy. We can put those under the same symbol there. Let's see, and then we've got, again, this one. This is going to square the 2 and give me 4. And the square root of y to the squared is going to get rid of everything but the y. And that's what I end up with, and that's the answer in the book. Thank goodness. Okay, bringing us to example 6. Now this is where they start getting not really a little tricky, but a little bit more thoughtful as you do this. So we can also use that same formula that we used on the last one. Whoops. Whenever I have this, a number minus a number, and the whole thing is squared, I can use this formula. Okay, so let's just do that. We're going to look at the first term and square it. Minus 2 times the first term times the second term plus the second term squared. Now, one of the things, remember, you do not have to look at this negative sign. It's already accounted for here. So you just look at the first term and the second term, ignore the negative sign. So see, I've got a 1 there without a negative, and I have a 1 there without a negative. So we're doing good that way. So x plus 2, the quantity squared, remember, 2 here, we can take off the radical sign. Doesn't matter what's under it. Okay? Just leave that in parentheses. Minus 2 square root of x plus 2. We don't need to show that because it's just times 1 plus 1. All right, so now we've got x plus 2 minus 2 square root of x plus 2 plus 1. So I can take that and add it together. That's all I can do. That's it. So we're done with that one. It's as simplified as we can go. So notice these aren't really too terrible. Hopefully you're not having too much trouble with them. Sometimes radicals can be really kind of scary and unnerving, but anyway, hopefully they're not too bad. All right, so when we have something like this where the first numbers are the same and the second numbers are the same and the difference is a plus and minus sign, we can rewrite this as a squared minus b squared, or the first term, or the first term minus the second term. Okay? Square root of 6 squared is just 6. Square root of 2 squared is just 2. So that gives us 4 for our answer. One of the things I want you to be aware of when you're looking at something like this, whenever you have the same first term and the same second term, and the only difference between them is one has a plus sign and one has a minus sign, we have what we call conjugates. These are conjugates. So if later on in the book, we'll start talking more about conjugates. But when we multiply conjugates, it always gives us a rational number. So anyway, just recognize that term. And when you see it again later in the book and you're like, okay, I remember we talked about conjugates. Well, that's what it is. All right, so I am going to go ahead and end this video to do the next couple problems, so we're not going into 20 minutes. So get ready for 6.5b.